joining me on Fascinating Frontiers, episode 109 for June 22nd, 2026. New week, new discoveries. Let's see what's happening. NASA's next flagship observatory has reached Florida for final checks before an August launch on a Falcon Heavy. The $4.3 billion Nancy Grace Roman Space Telescope touched down at Kennedy Space Center on June 21. It will spend roughly 70 days in pre-launch processing before riding a SpaceX Falcon Heavy no earlier than August 30. The telescope's wide-field infrared instrument is designed to survey large sky areas for exoplanets and dark energy measurements. Engineers will now integrate the spacecraft with its launch adapter and run final environmental tests. The observatory will head to an L2 halo orbit once those checks are complete. On a completely different note, we turn to the company that now dominates getting satellites into orbit in the first place. SpaceX has now launched more satellites than all other providers combined throughout history. The company's cumulative orbital deliveries exceed the total from every other launch operator to date. Reusable Falcon 9 first stages that return to landing platforms or ground pads after each flight drive the lead. No other operator has matched the flight rate or payload capacity achieved so far. Future Starship flights could widen the margin further once they enter regular service. While one operator scales quantity, another is preparing hardware to bring materials back from orbit. Astroscale has secured new capital to move from single demonstration flights to a sustained series of on-orbit servicing operations. The funds support development of rendezvous and capture hardware for multiple clients. Servicing spacecraft could extend the life of commercial and government satellites already in orbit. The shift marks a step toward routine orbital maintenance rather than one-off tests. Next milestones include hardware qualification and customer contracts. Keeping satellites alive is one challenge. Deciding what we might do with an entire planet is another. Researchers have mapped the measurements needed to judge whether warming Mars is feasible. The plan focuses on releasing greenhouse gases or deploying orbital mirrors to raise surface temperatures enough for liquid water. Key unknowns include how much carbon dioxide remains trapped in the polar caps and regolith. Data from current orbiters and future landers will feed into climate models that test each scenario. The study provides a clear checklist rather than claiming success is assured. Before we alter another world, we're learning how Earth life behaves in Mars-like conditions. Experiments expose microorganisms to low pressure, cold temperatures, and radiation levels modeled on the Martian surface. Several strains remained viable after the exposure period. The work also found that the same microbes triggered weaker immune responses in test subjects. Results suggest that any future sample return hardware must account for hardy terrestrial contaminants. The findings apply equally to protecting Earth from potential Martian material. While labs study microbes, a new commercial capsule aims to manufacture materials in orbit and return them. SpaceX is preparing a dish-shaped re-entry vehicle for a demonstration flight. The capsule is sized to return small batches of materials processed in microgravity. No prior commercial re-entry system has offered routine, low-cost sample return from orbit. Engineers are targeting markets such as fiber optics and pharmaceuticals that benefit from extended weightless processing. A successful test would open a new class of orbital production missions. From new hardware in orbit, we shift to how operators already keep thousands of satellites safely spaced. If every Starlink satellite were the size of a city bus, the shells they occupy would still be separated by only a few tens of kilometers vertically. Ground operators upload a small thrust command days ahead when two satellites approach. The nudge moves one craft a few hundred meters aside so their paths never intersect. The adjustment uses less than a kilogram of propellant per year per satellite because the relative velocities are modest and the warning time is long. At 550 kilometers altitude, the orbital period is roughly 95 minutes, so each satellite passes over any given ground point 15 times a day. The real puzzle is how operators will keep the same spacing once thousands more satellites from competing constellations join the same altitude bands. We can already compute the probability of close approaches, but no one yet knows the practical limit before active coordination becomes impossible. While city dwellers look up, communities once tied to coal are now building parts that go into orbit. The story follows how communities once centered on coal extraction are now contributing components and talent to space programs. Local manufacturers supply precision parts for launch vehicles and satellites. Workforce programs are retraining miners and engineers for aerospace roles. The transition illustrates one regional example of economic shifts tied to the space economy. More suppliers from the area are expected as launch demand grows. NGC 7000 in Cygnus reaches nearly 70 degrees elevation in the eastern sky by 2 a.m. local daylight time. The emission nebula's shape resembles the continent of North America when viewed through narrowband filters. Observers with modest telescopes or binoculars can locate it by sweeping from Deneb toward the Cygnus star cloud. The object is a favorite summer target because it lies in a rich Milky Way field. Clear, dark skies away from city lights give the best contrast. On Earth, ice is breaking up earlier. In the Bering Sea, satellites are already tracking the change. Satellite views captured drifting ice fragments near St. Lawrence and Nunavak Islands. Colorful sediment plumes around the Yukon Delta mark the seasonal transition. The imagery comes from instruments monitoring Arctic sea ice extent and ocean color. These observations help track how quickly open water appears each year. Continued monitoring will show whether the pattern repeats in coming seasons. The small Jackal spacecraft launched aboard the SACE 500-2 mission on May 3. It joined a cluster of other secondary payloads released into low Earth orbit. Tracking data confirm the satellite is operating as planned. Such rideshare flights allow rapid deployment of technology demonstrators without dedicated rockets. Additional details on its mission objectives are still limited. The Ad Astra event runs September 1 through 3 and will gather input on the next generation of large astrophysics observatories. Participants will help define science priorities and technology needs. The workshop is organized by NASA's Astrophysics Division. Outcomes are expected to feed into the upcoming decadal survey process. Registration details appear on the Cosmic Origins program site. The IR Stig Prima series features Bogdan Pestrav of the Institute of Space Science on June 22. Separate AGN and Cosmic Origins sessions run later in the week with early career presenters. Topics range from galaxy evolution to new instrumentation concepts. The talks are open to the community via the PCAST webpage. Recordings will be archived for later viewing. A new commentary examines whether large language models will favor rapid but conventional results over novel ideas. Reviewers and funders may need new incentives to reward unexpected findings. The piece notes that model training data already reflect past publication patterns. Without deliberate changes, the diversity of scientific questions could narrow. The discussion continues among journal editors and funding agencies. Dissertation work tested how simulated space travel alters microbial behavior. Results indicate that some Earth organisms could persist on icy worlds where liquid water exists. The research also has implications for crew health on long-duration missions. Supervisors note the dual use of the data for both extraterrestrial and terrestrial applications. Follow-on experiments are planned with additional microbe strains. Next time, we'll be watching for the first integration milestones on the Roman Space Telescope as it moves through its 70-day Florida campaign. That's Fascinating Frontiers for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for exploring with me, and I'll see you next time. And if you'd rather watch than listen, find us on YouTube at NARA Network, links in the show notes. And before you go, this show is part of the NARA Network, a family of daily podcasts covering tech, science, markets, and more. If you enjoyed today's episode, give Tesla Shorts time a listen. Your daily deep dive into everything Tesla. You can explore the whole lineup at naranetwork.com. This episode used AI voice synthesis of my voice. Editorial, selection, and analysis are my own.
drifting softly through